How much life has ever existed on Earth, and how much more life will exist on our planet? All organisms are made up of living cells. While it's difficult to pinpoint exactly when the first cells came to exist, geologists' best estimate suggests that at least as early as 3.8 billion years ago. But how much life has inhabited this planet since the first cell on Earth? And how much life will ever exist on our planet Earth? Every year, about 200 billion tons of carbon is taken up through what is known as primary production. During primary production, inorganic carbon, such as carbon dioxide in the atmosphere and bicarbonate in the ocean, is used for energy and to build the organic molecules life needs. Today, the most notable contributor to this effort is oxygenic photosynthesis, where sunlight and water are key ingredients. However, deciphering past rates of primary production has been a challenging task. In lieu of the time machine, scientists like myself, the writer writes, rely on clues left in ancient sedimentary rocks to reconstruct past environments. In the case of primary production, the isotopic composition of oxygen in the form of sulfate in ancient salt deposits allows for such estimates to be made. In our study, we compiled all previous estimates of ancient primary production derived through the method above, as well as many others. The outcome of this productivity census was that we were able to estimate that 100 quintillion or 100 billion tons of carbon has been through primary production since the origin of life. Big numbers like that are difficult to picture. 100 quintillion tons of carbon is about 100 times the amount of carbon contained within the Earth, a pretty impressive feat for Earth's primary producers. The primary production. Today, primary production is mainly achieved by plants on land and marine microorganisms such as algae and cyanobacteria. In the past, the proportion of these major contributors was very different. In the case of Earth's earliest history, primary production was mainly conducted by an entirely different group of organisms that don't rely on oxygenic photosynthesis to stay alive. A combination of different techniques has been able to give a sense of when different primary producers were most active in Earth's past. Examples of such techniques include identifying the oldest forests or using molecular fossils called biomarkers. In our study, we used this information to explore what organisms have contributed the most to Earth's historical primary production. We found that despite being late on the scene, land plants have likely contributed the most. However, it's also very plausible that cyanobacteria contributed the most. The total life? By determining how much primary production has ever occurred, and by identifying what organisms have been responsible for it, we were also able to estimate how much life has ever been on Earth. Today, one may be able to approximate how many humans exist based on how much food is consumed. Similarly, we were able to calibrate a ratio of primary production on how many cells exist in the modern environment. And despite the large variability in the number of cells per organism and the sizes of different cells, such as complications between secondary since single-celled microbes dominate global cell population, in the end we were able to estimate about 10 to the 30th power, that's 10 non-nillion cells exist today, and that between 10 to the 39th power, duodecillion, and 10 to the 40th power cells have ever existed on Earth. How much life will Earth ever have in the future? Save for the ability to move Earth into the orbit of a younger star, the lifetime of Earth's biosphere is limited. This morbid fact is a consequence of our star's life cycle. Since its birth, the sun has slowly been getting brighter over the past 4.5 billion years as hydrogen has been converted to helium in its core. Far in the future, about 2 billion years from now, all of the geochemical fail-safes that keep Earth habitable will be pushed past their limits. First, land plants will die off, and then eventually the oceans will boil, and the Earth will return to a largely lifeless rock planet as it was in its infancy. But until then, how much life will Earth house over its entire habitable lifetime? Projecting our current levels of primary productivity forward, we estimated that about 10 to the 40th cells will ever occupy the Earth. Earth as an exoplanet? Only a few decades ago, exoplanets, that's planets orbiting other stars, were just a hypothesis. Now we're able to not only detect them, but describe many aspects of thousands of far-off worlds around distant stars. But how does Earth compare to those bodies? In our new study, we've taken a bird's-eye view of life on Earth and have put forward Earth as a benchmark to compare other planets. What I find truly interesting, however, is what could have happened in Earth's past to produce a radically different trajectory and therefore a radically different amount of life that has been able to call Earth home. For example, what if oxygenic photosynthesis never took hold, or what if endosymbiosis never happened? Answers to such questions are what will drive my laboratory at Carleton University over the coming years. And this is written by Peter Crockford and colleagues, The Geologic History of Primary Productivity. And it's from the conversation here on phys.org. Of course, we know that our Earth has had a lot of geological changes. For example, the expanding Earth. It was not always the way it is now. At one point, we only had a day that lasted 6 hours. That's how small our Earth was, about the size of what our moon is now, today. And we've had a lot of extinction level events as well that almost wiped out all of life on Earth. One of them was about 13,000 years ago when we had the Younger Dryas comet impact. And also we had the Tapo super eruption, one of the super volcanoes of the Earth, the Tapo New Zealand super eruption that took place. And anthropologists claim that they estimate that only about 1,000 couples of humans remained alive after that eruption that took place about 27,000 years ago. And this is how the Earth has changed in millions of years from what you could see at one point. The first picture shows that Antarctica was flush up at the equator. You can imagine how many changes took place as the Earth grew, and is still growing. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.